Welcome to another episode from the Veterinary Medicine Digest. Today we are diving deep into a topic that touches the hearts of many pet owners and the daily practice of veterinarians around the world, which is the complex and often misunderstood process of brain aging in our senior companions. As our pets live longer lives thanks to advancements in nutrition and medical care, we are increasingly confronted with the reality of neurodegenerative decline. This condition, often referred to as canine cognitive dysfunction, or sometimes feline cognitive dysfunction, is much more than just a normal part of getting older. It is a pathological state that significantly impacts the quality of life for both the pet and the human family. To understand where we are going, we must first look at the biological foundation of this syndrome. Brain aging is a degenerative process that progresses toward a loss of cognitive domains, which includes memory, learning, and executive function. It is increasingly evident that dogs, and to a lesser extent cats, serve as spontaneous models for Alzheimer's disease in humans. When we look at the brains of aged dogs, we see the accumulation of a toxic substance called beta-amyloid protein, which forms extracellular plaques. These plaques are remarkably similar to those found in human patients suffering from dementia. While dogs do not always develop the mature neurofibrillary tangles seen in the late stages of human Alzheimer's disease, they do show evidence of hyperphosphorylated tau protein, which is considered a precursor to those tangles. This biological overlap means that what we learn about our pets can help humans, and the research into human medicine is vital for our veterinary patients. The prevalence of these behavioral changes is staggering, yet they are frequently underreported. Studies suggest that between 14 and 35% of the senior dog population is affected by some level of cognitive decline. However, when owners are not specifically asked about these signs, only a tiny fraction, perhaps less than 2%, receive a formal diagnosis from their veterinarian. Owners often assume that their dog is simply slowing down or getting a bit senile as a natural consequence of age. But we must distinguish between normal aging and pathological aging. Normal aging might involve a slight decrease in activity, but pathological decline leads to significant impairments in how an animal interacts with its world. Veterinarians use a specific framework to help owners identify these changes, often summarized by the categories of disorientation, social interactions, sleep-wake cycles, house soiling, and activity levels. Disorientation might look like a pet getting stuck in corners, staring blankly at walls, or failing to recognize familiar people and places. Changes in social interactions can be heartbreaking, as once affectionate pets may begin to avoid contact or, conversely, become overly dependent and clingy. One of the most common signs reported is the disruption of the sleep-wake cycle. Owners often describe their dogs pacing or vocalizing throughout the night and then sleeping deeply during the day. House soiling is another major indicator, where a previously well-trained pet begins to eliminate indoors, often right after coming back from a walk. Finally, changes in activity can range from a total lack of interest in play to repetitive, aimless behaviors like circling. The underlying causes of these behaviors are multifaceted. Beyond the beta-amyloid plaques we mentioned earlier, the aging brain suffers from oxidative damage. As the body ages, it produces more reactive oxygen species, which are free radicals that damage proteins, lipids, and even DNA. The brain is particularly vulnerable to this because it has high oxygen consumption and relatively low antioxidant defenses. We also see a decline in vital neurotransmitters such as dopamine, acetylcholine, norepinephrine, and gamma-aminobutyric acid. This neurotransmitter imbalance contributes to the confusion and anxiety we see in these geriatric patients. Furthermore, the brain's ability to use glucose, its primary energy source, diminishes as it ages. This is why we sometimes see a significant improvement when we provide alternative energy sources, such as ketone bodies derived from medium-chain triglycerides. Diagnosing canine cognitive dysfunction is a process of exclusion. Many medical conditions can mimic the signs of cognitive decline. For example, a dog that seems disoriented might actually be suffering from sensory decline, such as loss of vision or hearing, or perhaps chronic pain from osteoarthritis that makes it restless at night. Endocrine disorders like hypothyroidism or hyperadrenocorticism can also cause changes in activity and house soiling. Therefore, a thorough physical examination, including a neurological assessment and blood work, is essential before we can confidently point to the brain as the primary source of the problem. Advanced imaging, like magnetic resonance imaging, can also be useful. In dogs with cognitive decline, we often see evidence of brain atrophy, which manifests as widened cerebral sulci and a decrease in the thickness of the interthalamic adhesion. In fact, an interthalamic adhesion thickness of 5 millimeters or less is often consistent with a diagnosis of dementia in dogs. Once a diagnosis is made, our goal is to slow the progression and improve the quality of life. While we cannot cure this syndrome, we have several effective tools. Pharmaceutical intervention often begins with selegiline, which is a selective and irreversible inhibitor of monoamine oxidase B. This drug helps by enhancing dopamine levels and reducing the production of free radicals in the brain. Another option is Feline, which can increase blood flow to the brain and heart and may have neuroprotective properties. Nutrition plays a massive role in managing brain health. Diets enriched with antioxidants like vitamin E and C, as well as flavonoids and carotenoids from fruits and vegetables, have been shown to improve cognitive task performance in laboratory and pet dogs. As we mentioned earlier, medium-chain triglycerides are a game changer for many pets. By providing a bypass for the impaired glucose metabolism, these fats give the brain the energy it needs to function more effectively. Supplements containing phosphatidylserine, which is a membrane phospholipid, or S-adenosylL-methionine, which helps maintain cell membrane fluidity and increases glutathione production, can also provide significant benefits. Beyond diet and drugs, environmental enrichment is perhaps the most underrated therapeutic tool. The use it or lose it principle applies to the canine brain just as much as the human one. Continued mental stimulation through training, play, and exploration can help maintain cognitive function. Even simple changes like introducing new toys or taking different routes on walks can encourage the brain to form new synaptic connections. This concept is known as cognitive reserve, which is the idea that a brain that has been well stimulated throughout life has more backup pathways to use when the primary ones are damaged by disease. We should also consider integrative approaches, acupuncture and Chinese herbal therapy. Studies in rodent models and human clinical trials have shown that acupuncture can enhance neuronal glucose use and increase the production of neurotrophic factors that support brain health. Herbs like ginkgo biloba provide antioxidant and anti-inflammatory support, while Huperzia serrata can act as a procholinergic agent, helping to boost memory and learning. Now, we must turn our attention to an area of research that is shedding new light on how we perceive the clinical picture of aging in dogs. Specifically, we want to discuss the occurrence of myoclonus in geriatric dogs and its relationship with cognitive decline. Myoclonus is a term used to describe involuntary movements characterized by sudden, brief, shock-like muscle contractions. These jerks can affect a single muscle group or multiple areas of the body. In a recent and very significant study involving an online survey of over 400 pet owners, researchers sought to describe these movements in dogs that were also showing signs of canine cognitive dysfunction. The researchers found that among geriatric dogs over the age of 7, there was a very high co-occurrence between cognitive decline and myoclonus. In their study population, 89% of the dogs that were identified as having cognitive dysfunction based on a validated scoring scale also exhibited myoclonus. This is a striking number, although the researchers wisely pointed out that because the survey specifically asked about these two things, there might be some reporting bias involved. Nevertheless, it suggests that these sudden twitches might be a much more common feature of the aging brain than we previously recognized. When we look at the nature of these myoclonic jerks, we see that they predominantly occur spontaneously. About 72% of the owners reported that the twitches happened without any obvious trigger. However, for some dogs, these movements were induced by stress or even by exposure to light. Interestingly, noise-induced or feeding-induced triggers were much less common. Most of these episodes occurred during the day and were typically observed when the dog was at rest. In about half of the cases, multiple body parts were involved, with the head being the most frequently affected region. The question then becomes, why does this happen? In human medicine, we know that neurodegenerative disorders like Alzheimer's disease are often associated with what we call cortical network hyperexcitability. Essentially, as the brain's networks become damaged, the balance between excitation and inhibition is lost, which can lead to abnormal involuntary movements. Because we see such similar pathological changes in dogs, such as the accumulation of beta amyloid and synaptic dysfunction, it is highly plausible that these same mechanisms are contributing to the twitches we see in our senior pets. It is important for veterinarians to distinguish between different types of myoclonus. It can be physiological, like the hiccups we experience, or pathological, which is the type we are concerned with here. It can be classified by where it originates, whether in the cerebral cortex, the brainstem, or the spinal cord. It can also be classified as either epileptic or non-epileptic in nature. In the study we are discussing, only a small number of the dogs had a formal diagnosis of epilepsy, which suggests that for most of these geriatric dogs, the myoclonus has a non-epileptic origin and is more likely a direct consequence of the neurodegenerative process itself. Owners in the study reported using various medications to try to manage these twitches, including Feline, gabapentin, and in some cases levetiracetam. While some owners reported improvements, the results were variable, and we currently lack controlled studies to confirm which medications are truly effective for this specific symptom in the context of cognitive decline. However, it is worth noting that some dogs showed a complete resolution of myoclonus with the use of corticosteroids or gabapentin. This research highlights the importance of a comprehensive approach to the geriatric patient. When a dog is presented with myoclonus, canine cognitive dysfunction should definitely be on the list of differential diagnoses, especially if the owner is also reporting changes in the dog's behavior or daily routines. We are seeing a pattern where these brief, shock-like jerks are a concomitant feature of the aging brain, much like the disorientation or the sleep disturbances we have discussed. The challenges in this field are still significant. Because this specific study relied on owner-reported information through a survey, it lacked the confirmation of a direct veterinary diagnosis or objective neurological testing like an electroencephalogram. To truly understand the origin of these movements, we would need to record the electrical activity of the brain to see if they are coming from the cortex or subcortical regions. Furthermore, the study's cross-sectional design means it could not track how these twitches and the cognitive decline progressed together over time. However, the takeaway for all of us is that we must be proactive. We should not wait until a dog is severely impaired before we begin to look for these signs. Early identification of cognitive decline and its associated symptoms, like myoclonus, provides the best opportunity for effective intervention. We should be asking owners of pets as young as 7 or 8 years old about their behavior, their sleep patterns, and any unusual twitches they might have noticed. There are a few misconceptions that we must work to overcome in the veterinary community and among the public. First is the idea that mild impairment is just normal aging. It is not. It is often the start of a progressive disease state. Second is the belief that these conditions are rare. As we have seen, they are incredibly common in our senior population. Finally, there is the devastating misconception that nothing can be done. While we cannot cure the underlying degeneration, our multi-targeted approach combining specific medications, targeted nutrition, and meaningful environmental enrichment can dramatically improve the quality of life for these pets and extend the time they spend as interactive members of the family. As we move forward, the hope is that we will develop more objective ways to screen for these changes. While questionnaires are a fantastic starting point, they are subjective and can be influenced by the owner's perceptions or their own stress levels. Research is currently underway to develop batteries of neuropsychological tests, like the Vienna Canine Cognitive Battery, which can measure attention, learning, and memory more objectively in a clinical setting. These tools, combined with owner observations and potentially biomarkers in the blood or cerebrospinal fluid, will eventually allow us to catch this disease earlier and monitor the success of our treatments more accurately. The relationship between the pet and the owner is the core of veterinary medicine. When that bond is threatened by the behavioral changes of cognitive decline, the impact is profound. By understanding the science of the aging brain, from the toxic proteins to the neurotransmitter shifts and the sudden muscle jerks of myoclonus, we are better equipped to support our patients and their families through the golden years. We can provide the hearts and the tails of our companions with the light and the inspiration they deserve, even as the shadows of time begin to grow. Thank you for listening. The titles for the reference papers are in the video description. From VetMed Digest, where we keep minds inspired, hearts light, and tails wagging.